to hide. And, come on, don't do that to me. You said to go back to, hold on, where was I? Answers. Good. That's a good question as to what you should get out of that. With the box whisker plot, you want to remember what this is showing, and this is showing a center. You can see that that line is nicely centered over these ends. So that's one thing. Another thing is that the space here within this right side and left side, the space inside, that is trying to remember, because it's been a while since I've done the box whisker plots. That's like 1 quartile, or does someone remember? Yeah, I haven't done box whisker plots in a long time, but it's something about a quartile. And what you see is that the left and the right spaces are the same amount of space, showing asymmetry, but yet it's allowing for some extra outputs that aren't within a certain quartileness about the center. It would create, you don't want these boxes to go all the way out to the far edge, but you want to have a symmetry for what's inside the boxes from the center, and then the little lines poking out at the end being a reasonable, decent amount, basically. And it helps to look at the box whisker plot with this vertical graph right here to see how it's off center. And with that being off center, you've got an excess here from here, and then excess inside the box compared to, of above compared to below. And that shows a skewedness. Does that help with understanding what you're looking at with the box whisker? Okay. Yeah, I think you guys might. Do you even remember the last class you were in when you did box whisker plots? Don't even remember. Yeah. But basically, yeah, this is again showing, you can see this is skewed. I just need to look up exactly what quartile issue that is, because I just didn't recall that anytime recently. Okay, then is there anything, so let me make sure to clarify with 8 and 9, if you have the same standard deviation with different means, I can go back over to here with the classwork we did to show you that when we looked at the same standard deviation with different means, it was just a horizontal translation. But when it was the same mean, but a different standard deviation, that changed quite a bit. It changed the spread of the graph, and it also changed how high it went as well. But it would make sense that with a greater standard deviation, that means more spread out. And to create that more spread out, your frequency in the center is less in order to spread it out further. And So that's why for number 9, one would be wider than the other is really the biggest thing that you need to be aware of. And I'm realizing that this doesn't include the draw a sketch. So let me just say real quick, every time you draw a normal graph, you're drawing a bell curve like this. And I'm trying to do a halfway decent job at that. And you want to just realize if you change where the center is, so here, the center is here, you would get an identical graph if you had the center elsewhere. And I was trying to draw identical. And then if you're drawing a sketch of a normal curve with different standard deviations, then you've got one that's like this maybe for standard deviation 1, but standard deviation 4 is going to be if that noise made sense. And then over here, I realize this isn't exactly the easiest thing to just go estimate. So with estimating the standard deviation, what you're actually expected to do is approximate the points of inflection. So, you know, looking along here, the point of inflection is somewhere throughout this section that I'm drawing. You are yourself deciding about where you think that is. And I'm going to say maybe about here. Then I'm going to look at about where does that put me. And I'm going to go with what's easier because I'm estimating anyway. It looks like those points of inflection are located at 220 and 240, where the mean is 230. So when I look at that, I'm seeing that it looks like that's a standard deviation of 10. They have an estimate of 15. But again, it's an estimate and you're eyeballing this, and I decided to go with easier. You probably noticed it was out a little farther than what I drew because I didn't want to have to deal with, okay, it's at what, 243, 245? No, I don't know, somewhere around in there. You're just approximating. Especially since you're trying to, shall we say, guesstimate where that inflection point is. And when you have a steep graph like that, it's a lot harder to locate because with that steepness, it's almost straight. But with these other two graphs, it's a little bit easier to locate approximately. I'm going to say maybe about here, somewhere within here. Graph B is having an inflection point. And I'm thinking, I want to make my life easier, so maybe I'll go with 200 and 260. And that's probably going to be off a little bit, but they just said estimate. So the standard deviation with that is going to be 30, but it's probably a little bit more than 30. And they have 40. So yeah, that's a little bit more than 30. But the problem is you're eyeballing this. You would not be expected to eyeball where that point of inflection is and get it precise. So you're just kind of, again, you are estimating. And if you're estimating, your estimate is going to be a little different from someone else's estimate, and that's okay. Then when I look at graph C, Again, I'm looking for those points of inflection, and I would say maybe about there-ish. Could be a little bit, somewhere around in there. So it's probably a little farther than 300. And all I need to do is look at one of the points inflection, not the pair, and just look at the distance of one of those inflection points from the center. So that's about 70 units away, and they have 60. So I overestimated that one a little bit. But again, it's hard to eyeball exactly where that curve changes from being like that to being like that. Hold on one second. I didn't want to bother you with my throat clearing. So understand that you're not expected to necessarily get those three numbers, but that's what process you would take to come up with your own estimations. And then just to, is this enough clarity with the homework from yesterday? And I still am not online over here due to our lovely power outage. So give me a second because I can't see if you're asking questions. Gonna bring this over here. Join. Okay, so now if you type something into chat, I can see I've got that up. And all right, we're going to move on to today's classwork. We're not going to do everything in this classwork. We're just going to see what we're able to get through. Now, for these first couple of problems in your classwork, you are creating a histogram, a frequency histogram. So let me help you with getting started. One of my intervals is from 22 to 26. Now I take a look down here and I can see that I've got a 22 and a 26. And I'm going to draw a line in between those 2 points. I need to find out how many people or how many objects came out with the number between 22 and 26. And then from there, I'm going to bring that up to the quantity. So there is only one data item between 22 and 26. So that means that I am going to put that line at 1 to cover the 22 to 26. And you can shade or not shade, and then just keep doing this. So the next set of data is 26 to 30. So you're looking for what is between 26 and 30. And then the question is this including equal to 30? And if you take a look, I know it's not obvious, but this is showing equal to 30 to just under 34, whereas this one was equal to 26 and just under 30. So I actually only have one member there. Then the 30 is going to go with the next frequency. For the next frequency, we have 30 included, but not including 34. So now I have a frequency of 2. And so you're just going to continue doing that. So write down what the frequencies are, and then you are going to sketch that frequency over here. Ooh, I can draw rectangles. Let me try that. Is that, well, a so-so rectangle. Yeah, decent. Not exactly where I wanted it to be, but between 26 and 30. So right there, frequency of 1. I'll draw my next rectangle. Meanwhile, you guys are figuring out your frequency. I'm trying to make my rectangles the size I intended. And there you go. And you're just going to continue doing that with both of these first 2 problems. Keep working on that. And I want you to know that in the next problem, you are expected to sketch a normal distribution curve. When you sketch a normal distribution curve, you want to choose a center, and that's the highest point. You need to figure out how much is one standard deviation. Now, looking at this, I think I'm going to go with this is 1 standard deviation away from the center. And in order to draw this better, I think I'm going to put this lower so it's easier to read. I should have nice little points of inflection over here at 1 standard deviation away. And then as I go from 2 to 3 standard deviations, I get to having possibly everything or near everything within 3 standard deviations. So it should just about hit the graph right there on the axis, 3 deviations away. It's not going to be exactly perfect because it's trying to fit data, but that is theoretically what the graph should look like. How is the frequency table going? So I tried to give you a little bit of time to just work on that frequency table. And, oh, I can see over here. Oh, wait, why is it 2? The frequency there, you mean? What you're doing is you're looking at from 30 equal to 30 to less than 34. So it's actually looking at this kind of interval. It's looking at what are my data values, the x, with these being x's. In this inequality. That's what it is asking for. And so the numbers that are greater or equal to 30 while less than 34 are 30 and 32. Then 34 to 38, equal to 34 but not equal to 38. Oh dear, that's only 1. Then from 38 equal to 38 to 42, but not equal to 42. I have 2 items. Next is 42, including 42 to under 46. 2 more. Then 46 to 50, but under 50. There are 3. And then inclusive of 50 to under 54. 54 to under 58. 3. And you're just continuing to do that and then drawing the graphs. Now, using a calculator or a computer program, you can enter this data set and you can figure out what the mean is of that. And I'm going to throw the answers at you now to take a look. I've only got 10 minutes left of class, really? Okay, whatever. By the way, tomorrow I will not give you any homework. Tomorrow is just whatever we do in class and we're done. So, based on that, I'm going to say, I want you to finish these frequency distributions. I will post the answers up so you can see the answers, but I want you to finish those 2. And I want to, stop screen, stop it. Yay. Okay, this, let's take a look at it. It says for the ACT, in 2010, the mean score was 21. And the standard deviation was 5.2. So 21 plus 5.2 is 26.2. Plus another 5.2, and basically just continue that for 3 standard deviations. Yeah. And that gives you the following numbers. And you want to be familiar with standard deviation and the numbers that we had gotten yesterday, but I know people were leaving really quickly at the end of yesterday. So let me point out the empirical rule of 68, 95, 99.7. Remember, this is theoretical, not necessarily what actually happens with every single set of data. So if you look at these numbers, this is theoretically an approximate. It is as far as what these percentages are giving. Based on the information, this is showing that 90, what, now I forget the percentage number. Let me look at it again. Yeah, but they do. Why can I not find it now? Because I can't, because I'm in the wrong area. Ha ha ha. There it is. 68, 95, 99.7. So 99.7% of your ACT test takers I'm trying to get things done in too quick of a quantity of time, but there are some more people on these outer edges. It is 0.3%. It is a very, very small amount that are outliers. Then as far as what are you going to do with the questions that are there, and I'll just go back to the answers and deal with it. Okay, if your mean is 21 and it asks what percentage of the test takers score below 21, that is expected to be half of the people, 50%. These questions are based on using that rule of 68, 95, 99.7. About what percentage is below 16? Now, one standard deviation away is a number very close to 16. So the easiest thing you can do, because you are approximating, is to say, well, what percentage of the test takers are expected to be under one standard deviation? And then it's all about percentages. It is looking at, you've got 50% are under 21, 34% is within one standard deviation away. So then you're looking at what is 50% minus 34% to get how many are more than one standard deviation under. And that happens to be 16%. And that is an approximation. The next question is about what percent scored between 11 and 26. So again, it's about what percent. It's not asking exact. A asked exact because it gave you the median. You know 50% are under the median. That's how it is normally distributed. So between 11 and 26, you're looking at 13.5% plus 34% plus 34%, and that's it. 68% is within one standard deviation, but then we're only adding to that what is between under 1 and 2 standard deviations, which is going to add a 13.5%. That's trying to write a 13. And so that takes you to approximately 81.5%. Now, we are getting close to out of time. And I want to be a little bit careful with what I decide to do. I'm trying to decide what should I cover, what is most important to cover in 3 minutes. I think I'm going to go over here because I really want to emphasize the normal curve to you and the familiarization with the percentages. 68% are within one standard deviation. And I want to go back to that really special trio of numbers. 68% are within one standard deviation, 95% are within 2 standard deviations, and 99.7% are within 3 standard deviations. That, if there's anything that you're going to get out of between yesterday and today, that rule with the understanding of the normal curve and just recognizing the meaning of standard deviation if you didn't already know it, that would be basically what matters.